All right, so it's 10 o'clock, and we're scheduled to start the webinar at 10 o'clock. So we've got quite a few people here today, so we'll go ahead and get started. Welcome to the Ask the Expert webinar on language identification and repeated content identification. My name is Dan Sullivan. I'm a level 2 technician in the search and analytics team. I was on the search and analytics team up until earlier this week. I finally transitioned over to the data grid team. So I'm interested in searching and indexing and all sorts of things like that. I'm kind of a geek for it. Today's webinar will be on language identification and repeated content ID. We'll have plenty of time for Q&A. I'll answer questions at the end of the webinar, but feel free to ask. We do have over 150 people on the webinar today, so if I don't get to your question, it's nothing personal. I'll just try to answer them as quickly as I can in the order that they come in. But first, just a little bit of background and whatnot. As far as the webinar itself goes, right, we want to make sure that everybody can hear the presenter and see the presenter's screen. And we have had issues like that in the past where we haven't been able to see the screen, or I've forgotten to share my screen, stuff like that. I've got a little really badly placed button on my microphone that I sometimes bump during the webinar and turn audio off. Looks like you guys are used to this drill already because I'm seeing a bunch of yeses here. I was going to say, if you can just type in the question box to let me know that you guys can hear me and see my screen. Yep, I see a bunch of yeses just scrolling on by. Perfect. Awesome. I will try to keep an eye on that question box during the course of the webinar, just in case I do bump the button that turns audio off. I've done that once or twice before. So if it seems like I'm wool gathering, I'm probably just checking that question box to make sure nobody's saying, "Hey, your audio went out all of a sudden." All right, perfect. All right, so our agenda today. Both of the functions that we're going to talk about are included in structured analytics. So we'll talk just a little bit about structured analytics. We'll talk about language identification and repeated content identification, and then we'll have plenty of time for questions at the end of the webinar. So structured analytics, most of you guys are probably familiar with this, but structured analytics is an application in Relativity. It comes with your installation of Relativity. So right out of the box, you've got the analytics application, and you can install it to any workspace. And I'll show you where that is later. So if you want to use these functionalities in a particular workspace, the structured analytics application has to be installed. Structured analytics gives you a set of tools that analyze text based on predefined properties. Includes things like email threading, textual and duplicate identification, and the two things that we'll talk about today, language ID and repeated content ID. It's a structural analysis, so this is a different way to use the analytics engine. We've had the ability to do conceptual indexes for quite a long time, but that is a different way to use the tool. So things like word order actually matter in structured analytics. They don't in a conceptual analysis. So language ID itself, I feel that this is sort of the simplest of the structured analytics operations. There are not a lot of levers to pull here. You don't have any settings that you can really adjust. It's pretty much you run this against a set of documents, and what you get is what you get. It determines a document's primary language and up to 2 secondary languages. It allows you to see how many languages are present in your collection, the percentages of each language by document. So if you've got documents that have commingled English and German, for example, you could see that. That way you could easily filter documents by language, batch those files out to native speakers if you needed to. And as of Relativity 9, we can identify up to 173 different languages. So there was a significant change to the algorithm from Relativity 8 to Relativity 9. And the algorithm in Relativity 9, while it's still not perfect, it is much, much stronger. And the reports of misidentified documents has gone way, way down. In fact, I can't remember the last time I got a ticket on a set of misidentified documents in Relativity 9. Used to happen all the time in Relativity 8. In Relativity 8, we were limited to something like, I think it was like 12 languages. It was a very small amount, and we would consistently see things like a document that was in Spanish being identified as Finnish or something crazy like that. So I haven't seen that in a while. It could probably still happen, and if it does, we would ask you guys to let us know about it. We're always looking to improve the engine. If you're curious about which languages are supported, and like I said, it's quite a few at this point, this page in the documentation is invaluable, the supported languages matrix page. You can see from this slide, this is under the system guides, and it shows you the supported languages, not only for structured language or structured analytics and language identification, but also processing, OCR, what will display properly in the viewer, et cetera, et cetera, et cetera. So lots of good information on this page. I still use the doc site all the time. So how does language identification work? There's no word list here or any kind of dictionary. It really does analysis on the writing. So each document is looked at, and it sort of picks apart these qualities to examine, does it contain a known language? So there are some character sets that are extremely distinctive. Thai and Greek, for example, if it sees these character sets, it can tell pretty much right away these are this is a Thai document or this is a Greek document. It looks at the letters, and in this case, most of Relativity and most indexes are accent insensitive, but language identification is sensitive to the presence or absence of accent marks. So that is something that it takes into consideration as it does the analysis. The spelling of words is taken into account, and when I say the spelling of words is taken into account, what I'm really talking about is it analyzes quadgrams, which I'll get to in a second. So for some languages, Chinese, Japanese, Korean, we get scores on single letters rather than multi-letter combinations. But for most languages, it doesn't actually do an analysis on a single letter. It uses quadgrams. And I had a kind of confusing slide that I decided to take out of the deck, but if you were interested, I could send you guys a link to it. It was just a Wikipedia link that it was the link to n-grams, n-gram. If you search that, you'll get to what I'm talking about here, and you'll see some really good examples of what a quadgram is. So it uses those quadgrams, scores each quadgram with several languages from most likely to least likely, and then repeats that process throughout the document, and then we get this aggregate score, and that's ultimately what we wind up with when that's what gets posted back to Relativity, in other words. Punctuation is ignored in this case, and HTML tags are also ignored. So there are some things that it sort of strips out or doesn't consider as it does the analysis. We do find that it works best on sets of at least 200 characters. So the documents that still get misidentified tend to be things like calendar invites or very, very short documents. But if we've got a couple of sentences of text, it does a pretty darn good job. So once you've run language identification, and a little bit later on, I'll just show you how to set it up. But again, there aren't very many levers here. It's pretty much, you push a button to say, identify these documents, and that's pretty much all the user input you've got, aside from defining which documents you want to run that on. So you do that, and then you can use that information. Here I've got a screenshot of, I just set this up a couple of days ago to kind of show you how you can use this in 9.4. I set up a couple of widgets here. Both of these are just a pivot of primary language grand totals. One's a bar chart, one's a pie chart. We can use these to filter and sort and drill into particular document sets, get some idea of what's going on in our workspace as it pertains to languages. So we could say, oh, you know what, we've got a lot of French documents here. Perhaps we should consider sending those French documents out for translation, or hiring a reviewer who speaks French natively. Because this is really a good way to help you organize your data, typically people would run language identification towards the beginning of their case. Certainly, you know, I understand that that our clients do rolling loads where they're constantly loading new documents in, but this is the kind of thing that can help you kind of get a jump start on your review in terms of organization. Again, figuring out if you've got to hire those native speakers or send the documents out for translation. One thing that I'll also mention here is, just given the nature of language identification, although you can run incremental analysis on language identification, it's really not necessary. I would just say, you know, you can just as easily start a brand new language identification set. Unlike some of the other structured analytics functionalities where you have, for example, in email threading or textual near duplicate identification, the results of one document may change a little bit depending on what else has been added. You know, whether or not the document is a dupe spare, for example, or what order the emails were sent in may change based on the addition of new documents. Unlike those functionalities, Language ID is on a doc by doc basis. It's per document. So the scores of the languages on one document don't affect another. So although you can do an incremental build, you might even just decide to go ahead and do a separate and new set if you were doing something like rolling loads where you were constantly bringing new data in. This is just another slide that shows how you can use filters to drill into the results of language identification a little bit further. So I just set a couple of filters over on the search panel here in Relativity 9.4, and you can see I've just sort of reduced what I'm looking at in scope, and maybe the results are a little more clear when you cut things down a little bit. One thing that I really like, and that I thought for the longest time with the fluid UI, I had a hard time using it personally because I couldn't do things like set column filters and automatically get results back. But that's changed. We can do that now. So I really feel like the Fluid UI is finally starting to really come into its own, and it's going to lead to some really interesting sort of cross-pollination of the data, if you will. So definitely something I would say, you know, I would encourage you to use it, and just look at the different ways that you can manipulate some of these data. I do see a question here. Jonathan, I will make sure that I answer this question at the end of our training when we get to the Q&A. So again, language ID of the structured analytics operations tends to be the most straightforward, the most simple. There's really not very much to it in terms of setup, and even the results are pretty straightforward, I feel. So let's move on to repeated content identification. All right, so with repeated content identification, it is a structured analytics operation, but really what it's meant for is creating the cleanest conceptual index that we possibly can. Depending on how we set up our repeated content ID, we can really ensure that the infrastructure is optimized for the best performance of these sets. So let's talk about it a little bit. What we're after with repeated content is the non-authored content that should be filtered out of an analytics index. So I don't want to get too far off track here, but I'm assuming most of you guys already have a pretty firm understanding of how analytics indexes work. But to just kind of put this in context, conceptual indexes form relationships between documents based on term frequency and co-occurrence. So, for example, when we talk about something like breakfast, maybe you guys can tell I'm hungry. When we talk about something like breakfast, we're likely to talk about things like eggs and bacon and coffee and tea and toast and jam and maybe a Danish or cereal. So these words kind of all co-occur together. And if they co-occur across a set of documents, then those documents will be tied together conceptually. So that's a very, very sort of kind of dumbed down and basic way of explaining how conceptual indexes work, but it's useful for our purposes because what we're doing with repeated content is essentially saying we don't want documents to have false relationships based on non-authored text, stuff that wasn't actually written by a human being and isn't conceptual in nature, but is present as a piece of text in our document set. So perfect example is something like a boilerplate footer, static repeated text. Like here we've got this, the foregoing email communication together with any attachments thereto is intended for the designated recipient. You guys can probably see this this red box here around the footer. So it's good for filtering those kinds of things out that occur over and over again in a document set, but we wouldn't necessarily want it to be considered as part of our conceptual analysis. So things like boilerplate messages, security disclaimers, confidentiality footers, all of those things is really what we're looking to strip out with repeated content. Now, unlike language identification, with repeated content ID, we've got some levers we can pull, some dials we can twist to affect what we get. We've got a minimum number of occurrences. Pretty self-explanatory, but this is how many times must a particular phrase occur in the data set to be considered repeated content. Then the minimum number of words. The repeated content phrase must be at least this many words long. Maximum number of words. This presents an upper bound to our filter. The maximum number of lines to return. The filter is going to stop at this number of lines. And the number of tail lines to analyze. So this is the number of lines that is examined for repeated content starting at the bottom of a document. One thing that I feel is worth mentioning right here is that what I might think of as a line as a human being is a little bit different than how the engine thinks of lines. So as far as the engine is concerned, a line is where some kind of line break occurs, like a carriage return. We've debated internally on whether or not we want to expose this number of tail lines to analyze, because we do find that that when this is set very, very high, it uses an enormous amount of memory. So a couple of just good practices when you're setting up repeated content. A good setting for the minimum number of occurrences would be something along the lines of 0.5% of the document set. For example, if you had a document universe of 10 million documents and your minimum number of occurrences was 50, you're going to wind up with with far, far more filters than you would really want and are useful. It also does contribute to the overall memory use on the analytics server if you've got a low minimum number of occurrences setting, because it's got more and more items that it's got to track as repeated content. And repeated content identification in general is even more of a memory hog than some of the other operations like email threading. We talked about this a little bit already, but just to reiterate, be very careful with the tail lines to analyze setting. A tail line for the purposes of repeated content is where text is separated by one or more carriage returns. If you bump this setting up, you're going to wind up analyzing entire documents, and you'll use so much memory that I've seen even fairly powerful servers, with 64 gig or 128 gig, absolutely just brought to their knees. What'll happen from what I have seen is that ultimately it uses so much memory that that the operating system has to choose between itself and Java, which is running all these content analyst repeated content operations. The operating system will choose itself over Java, so the Java application will crash at that point. The error that you get in the front end looks like a network error. It's not really a network error. Really what's happened is that Java is crashed so that communication to the analytics server has been temporarily interrupted. I would definitely say that setting is something that you probably don't want to play around with too much, although we'll talk a little bit more about this in just a second. Also, remember that once we've identified a piece of repeated content, it's going to be stripped out when we build the index, no matter where it appears in the text. So, we get a piece of repeated content from the tail lines of one email, but then if we've got a long email thread where there's a lot of exchanges and that particular piece of repeated content appears over and over and over again, when we actually apply the repeated content filter, it's going to strip it out of the document no matter where it appears. So even though we're only analyzing potentially the last few tail lines, once we've identified a piece of content as repeated, it'll be stripped out no matter where it appears. So let's talk a little bit about those tail lines and what that looks like from a human standpoint versus a computer standpoint. I just mocked up this email to show you guys this. So you guys, probably some of you guys have seen the lorem ipsum text before, but to me this looks like potentially, I don't know, maybe 20 lines or something like that. If I were to just count them, it's like, hi Rebecca is one line. I just wanted to write up as a second line. Free to ignore this message is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got something like 16 lines in here. It's not a very long email. As far as the engine is concerned, we have 11 lines here because there aren't actually carriage returns breaking up the paragraphs. And when you think about it, that's pretty common. So if we were to run repeated content identification against this particular email, we'd analyze the entire thing. This is why if you start bumping that repeated content tail lines to analyze up to double what its default is, so its default's to 16, but if you were to bump it to 32, now you're analyzing potentially 3 or 4 emails in a thread. It's a lot for the engine to do, so just something to keep in mind. Right, so let's also talk about minimum occurrence setting versus runtime. So this is something we did some testing on a 2 million record set, and we do find that kind of no matter how the minimum occurrence setting is changed, we don't see a huge effect on operation runtime. The task completion time doesn't include export or import. This is purely, for those of you familiar with structured analytics, phase 2, where the actual analysis is taking place. But you can see that that particular setting doesn't have a huge effect on the runtime. What it does have a dramatic impact on is the number of filters returned. So here, a smaller minimum occurrence setting is going to generate many more filters. For example, here you can see against a 2 million record set, if we have a minimum occurrence of 500, we get about 1,300 filters back. If we lower that to 100, we get 10,000 filters back. It's probably far more than we would actually want to apply to an index. So how many filters is too many when we're talking about applying these filters to an index? For a 1 million record index, the number of filters doesn't seem to affect the population time until we get to about 1,000 to 1,500 filters. One thing to keep in mind, though, is that as you add the filters to the profile, it starts to get pretty tedious at numbers that high. When I was doing this test, I was adding 200 filters at a time, and each additional set of filters that I added took about 10 seconds to add. Also, if you're adding these filters from the profile page, you can't view more than 1,000 filters at a time. And I'll do a little bit of a demo on how we can kind of circumvent this, or where might be a better place to do your analysis. So in general, we would recommend to limit your filters to no more than about 1,000. It is definitely possible to populate an index with more than 1,000 filters, but it does start at a certain point to impact the speed with which the index populates, and just overall ease of use in terms of adding the filters. So you can see, up at 1,000, we stay relatively flat all the way to about 1,500. We start going up, and then it starts to go up pretty dramatically until we're at 4,000 filters. We're talking double the population time. This was on 1 million documents, so you can imagine I've seen some, the trend has been that people are running analytics operations on larger and larger and larger document sets. I've started to see, indexes and structured analytics sets on 20 million plus documents. So, if we were talking 4 hours to populate an index with 4,000 filters, be pretty much a linear extension of that. So you're talking a couple of days at the very least if you add a 10 million document set or a 20 million document set. All right, so taking all this in mind, one workflow option that that's often overlooked, and this is something that I have done with a couple of clients, and that is something that we're probably going to start looking into more and more, testing more and more, and may even, we haven't really defined it as a best practice yet, but the indications that we have so far is that this is a good idea. Sampling for repeated content. For example, this can allow you to do repeated content on sets that your server wouldn't otherwise be able to handle. About a year ago, I can't remember which client it was, but I was working with a client who was doing essentially just kind of testing out analytics functionality, and they just wanted to see how everything worked and make sure that they understood the different practices and uses. And they had a small analytics server. Our minimum requirement for a production analytics server is 32 gigs of memory. Well, this wasn't a production server. It had 8 gigs of memory. And, and it wasn't really, especially, in this little test environment, it wasn't really, feasible or even a good idea to add more memory, but he had quite a few documents. I want to say he had about 5 or 6 million documents, and it was just too much for his server. If you start looking at our documentation, you'll see a line in there that says generally you're going to use about 6 gigs of memory per million documents. My personal finding has been that it's more like 8 to 10 per million documents, but that may just be support bias. That may just be because I'm in tech support and people don't report things to me when they're not a problem. Nobody calls me up and says, hey, I did this and everything worked out fine. So they tried to run repeated content against all their documents, and they just didn't have the memory to do it. So what we decided to do was take a random sample of 10% of the total document set and adjust our minimum number of occurrences accordingly, and we were able to complete the operation that way. And one of my colleagues, Jeff Joas, has been doing a lot more research into this lately. He's actually got a webinar coming up, in 2 weeks. I'll get you an exact date here in a second. It's about 2 weeks, and he's going to go over this in a little more detail. So let's say you did have a server that was really powerful and could handle, millions and millions of documents. You can still potentially save yourself just some time by sampling from that document universe and running repeated content against the sample. And Jeff gets into this a little bit more. Essentially what he's been finding is that if you use a sample of about 100,000 documents, RCID is such a resources hog. This smaller set saves you from running a huge RAM load, and most of what the analytic algorithm finds over the course of analyzing millions and millions of emails are rare repeated expressions. So not only are we using a lot of resources, but we're wasting our time on junk. And his experiments so far get a little bit into math that I understand in the context of assisted review, but haven't really looked at in terms of this. Essentially, what our margin of error is. What are we going to miss if we use a sample size of 100,000 documents? And we're finding that it's not much, and the stuff that we're missing is not particularly useful. So we're considering starting to recommend a fixed sample of 100,000 documents and a number of repeated, a number of minimum occurrences of right around 0.5%, where we get just about everything that we really need to, even in populations of 10 million documents. So this is definitely something, if you guys are interested in this and a better explanation of it, Jeff's webinar is coming up on October 25th at 1 p.m. and October 26th at 6 p.m. And it's called Creating an Optimized Analytics Index, Smarter, Easier, and Faster. So one other thing, and again, we're still doing some experimentation with this, is that the reduced load from the smaller doc volume might also allow us to loosen other settings to improve the overall results. So maybe with this settings, bumping the number of tail lines starts to get a little bit easier for us to do. So definitely something, it's pretty new. We've really just started talking about this workflow, but everything that I'm seeing so far indicates that this is a pretty good idea. Now, I've already done this workflow with a couple of clients, again, who just didn't have enough power in their server to handle the full document universe that they wanted to run repeated content on, and that's come out well. So far we're seeing really good results with these kinds of things. I do see a couple more questions, and I promise I will come back to these. I'm not ignoring you guys who are who are asking questions. We're almost done with the slideshow, so we're going to get there pretty soon. So the last thing that I kind of wanted to get in and just do a little bit of demo on is making sure you sort of understand, like, you know, maybe some of the best ways to choose these filters and whatnot. So I'm going to go ahead and switch over to Relativity and just do a little bit of demo work, and then we'll start to get into Q&A. Okay, so of course my session is about to expire. Oh, looks like I might have actually caught it in time. Great. So here I am in Relativity, and I guess before I get too much further, I just want to show you guys that structured analytics application, because in my opinion, it's not super intuitive to figure out which one it is. I'm going to go back out to home mode first, and we'll take a quick look at the libraries, so the application library specifically. Okay, within this application library, we've got a couple of applications related to analytics functionality. We've got Analytics Core, we've got Assisted Review, and then we've got this thing that's just called Analytics. I really wish that they'd decided to call this thing that's just Analytics. I really wish they'd called it Structured Analytics. But no, it's just Analytics, and Analytics Core handles all the conceptual functionality, things like building concept indexes, clustering, categorization, and this app called Just Analytics, well, that's the one that allows you to do email threading and repeated content ID. All right, so we can install this to any workspace that we want to use analytics functionality on. I would personally say that, you know, if possible, go ahead and install it into your template case. You can always lock the tabs away so that it's invisible to whoever's actually working the case, but then it's there if you need it. That's a little more attractive than trying to install the application into a live case, especially if that live case is big, because there are a couple of relational fields that get created, and I have seen those in some extreme circumstances time out. So if you can get it in your template case, probably save yourself a little bit of frustration. All right, so once we've got that application installed, we get a tab called Indexing and Analytics. And from here, we have a subtab called Structured Analytics, where we can set these different functionalities up. I've already got some stuff run here, but just to kind of show you guys this, if I click on New Structured Analytics Set, I have to give it a name, just like anything else. Then I choose the operations that I want to run. Email threading, textual and duplicate identification, language ID, and repeated content ID. Depending on my selections here, I will get additional parts of this layout. So if I choose repeated content identification, I get a section of the layout down here where I can twist those dials that I talked about earlier. Notice that with language identification, there is no additional part of the layout. Again, that's what I meant when I said it's the most straightforward, and we don't really have anything that we can adjust to change the results. In addition to choosing the operations, we have to choose a document set to analyze. This is just going to be a safe search. So whatever safe search you want it to name, we could set it up here. We can optionally use regular expressions, and I'll talk about this a little bit too when we switch over to the repeated content filters tab. I haven't seen too many use cases that I can think of for using a regular expression with repeated content identification or with language identification. You might, if you had, potentially, maybe you knew that there were a couple of people from a company who had a tagline that was in a foreign language that was kind of a joke or something, then maybe you could use those that regular expression to kind of filter that stuff out, so you didn't wind up with like 1% Latin or something in your analysis. But really, I haven't seen anybody use these in real life. Mostly, the regular expressions come into play for email threading. If we have more than one analytics server, we can choose a specific analytics server. In another webinar, I talk about optimizing your analytics servers, and you can optimize a server to handle conceptual functionality or structured functionality. So if you had one that was set up for structured functionality, you might choose it. If you don't, if you just have the one server, you can just choose automatic. And because some of these processes can take a while, like a lot of the other indexing and automatic features in Relativity, we can say, hey, just send us an email when something happens, rather than sit here and try to babysit the set. So I think that's about as much as I really want to say when it comes to structured analytics specifically. Let's talk a little about the output. So I'm going to go back to my just general structured analytics set, and I'll start with language ID. So I'll go into my language identification set, and you'll notice that one of the things that we have here is a hyperlink to a summary. I'll go ahead and click on that. Take a couple of seconds to load. So one thing that I know our clients have asked us for, and that I would really like to see happen at some point is, quite honestly, this bar chart is pretty crowded. So I'd like to see this adjusted in some way to make it a little bit easier to actually tell what's going on. Like even up here, for example, when we're looking at just French, Chinese, and Spanish, it's like, okay, what's the 8 versus the 11%, or the 5 versus the 8%? So I'd like to see that adjusted a little bit. What's probably a little more easy to use is just the table down here. So in addition to this report, we can set up pivots and whatnot on this stuff. So I did that with this particular environment. I just set up a bar chart that's like a count to primary language. And can you guys see the auto run search feature down here? I don't know if you guys can see that. Just to make sure that you can, let me actually see if I can. Of course, it doesn't want to cooperate with me. Geez, come on. Well, if you can't see it, take my word for it that, okay, perfect. Okay, good. I'm seeing that it is visible. Good, good, good. So I've got this set on, and what this does is when I start clicking around on some of these things, it's going to filter for me automatically. So if I wanted to see French documents, I could click here, or click here, for example, and see just the French documents. The pivot automatically reruns. The document set changes. You can see I've got 12 items here. And then if I wanted to clear this out, I could just click clear all conditions, and it runs my search again. So this is fairly new, the auto run search feature. It used to be that you had like kind of laboriously stack these conditions up and then click run search. And then when you removed the conditions, you had to click run search. So I really like the addition of this auto run. I think it's another item that's starting to bring the fluid UI into a state where I think it's really going to be cool. Personally, I still feel we've got some work to do on it. I'd like to see things be a little bit snappier and whatnot, but it's starting to come into its own, and it's starting to be pretty cool. So we can look at the primary languages that way, and of course we can change this however we want. You know, if we thought a table would be better, we could get a table. If we thought a bar chart would be better, we could get a bar chart. And if we wanted to, we could organize that horizontally. That's this would require quite a bit of real estate to really look good, in my opinion. So you'd probably, you know, you'd have your list down here and this up here. But again, you can have more than one of these up at the same time and cross-pollinate. So you could see, for example, how many French documents were coded responsive, or how many Russian documents were coded with privilege. So it's going to start to really, I think, yield some interesting ways to look at the data. I'll set this back to my pie chart, I think. Adjust this just a little bit. Okay, so that's really language ID. Again, it's fairly straightforward. Let's talk a little bit about repeated content. So if I go back to my indexing and analytics, under the repeated content filters section, these are the results of the repeated content job that I ran. I don't know if I pointed it out. I'll skip back over here just to show you guys. I do have a repeated content ID set that was already run. And if I click on View Repeated Content Filter Results, it really just takes me to kind of a special subsection of this tab. I'll go ahead and do that anyway, where I've got a filter automatically applied. In my case, filter or no filter, the results aren't going to change here very much, but if you add multiple repeated content, then potentially you would want to filter on the different sets. I'll just go ahead and clear my condition there. Okay, so as we look at this repeated content, we've got a number of fields that get populated here. Name and type are the first two. The names for automatically generated repeated content show you when the repeated content was generated and using what settings. So this one was generated at 3:27 p.m. with a minimum occurrences of 10, a maximum occurrences of 100, et cetera, et cetera. The type here, repeated content, that's all you're going to get out of actually running the repeated content identification in structured analytics. But if I wanted to create my own, I could certainly do that. Works just like anything else. I click on the new repeated content filter, and here I've got the ability to also set a regular expression in addition to repeated content. One thing to kind of keep in mind here is that the regular expression, if you were to set one up, would require a working methodology or sort of a knowledge of the working methodology of regular expressions. With repeated content, that's kind of done for you. I don't want to get too far into the weeds, but in the back end, repeated content actually gets converted to a sort of long regular expression where the different repeated contents are concatenated together in kind of a long regex, and that's how the filter works. So do know that you can make your own repeated content and regular expressions here. Thank you so much for attending. I really appreciate it. Have a great morning, evening, afternoon, wherever you may be. Thank you so much, and take care.